So here I'm going to derive the false position method. So if you have bisection method, you can go and watch that. Okay, so false position method is another method to find the root, to approximate the root. So we're also going to use this one to approximate the root. So suppose again here I'm just going to derive the equation. I'm not going to use it. So in my next video I'm going to show you actual examples where I'm using the false position method. So here we're deriving formula. So we're deriving the formula for false position. So suppose you have a function that's continuous on the closed interval AB. You have a function, this function is called f. This is f, and you know that this is going to be f of x on the y, and this is going to be x. Let me try to write a big diagram so that you can see clear. Okay, so we have this. So this function is called f of x, and this side is y, or is f of x, and this side is x. All right, so we said that this function is continuous on the interval, closed interval AB. Okay, so closed interval AB. So we want to approximate the root for this function. So what we're doing, remember that for last method, bisection method, each and every time we're taking finding the half of the interval, which you see was given by half a plus b. So we've divided. So this is easy. It's easy to find the root, but it's extremely slow. That's why we developed another method to find. For this one, it's going to be a bit faster compared to the bisection method. So here we're going to draw a straight line. Since we have a root here, we're going to draw a straight line from point A straight to point B. A straight line. You will excuse my line, it's not that straight. A straight line from point A up to point B. So we are going to find the function for that straight line, and we are going to find the intersection for that straight line. Since we know the function of a straight line, so this is a nonlinear function. We don't know what's the function is this, or what kind of polynomial, or sometimes nonlinear is that. So we going to find the equation for this straight line. So this straight line, remember that the equation for straight line is given by y minus y1 is equal to m, which is a gradient, open bracket, x minus x1 and plus c. So since this, to find the root here, when you are finding the root, this straight line each and every time is going to decrease, up until the straight line is on the root. So this c here, we're going to omit it because it's going to be 0 even if we include that c. Okay, so from this here we can see that if we call this point here, this is a point 1 and this is point 2. So y minus y1, you come here. What's y1? y1 is going to be the f of a here. So you say f of a is equal to m. What's the gradient? M. From the lowest grade we did that gradient is f of b, the y there, minus f of a divided by b minus a. This is y, and this was supposed to be here, so I'm just going to write m, and x stay as x minus x1 is this first point, and we call that a. Okay, so after that we can make y the subject of the formula, which is a function of this. So it's going to be y is equal to f of a plus the gradient, which is this, is going to be f of b minus f of a divided by b minus a, and open bracket x minus a. So where are we trying to find the value? We're trying to find this value here. So what's y there? Here y is 0. we don't have the y not there, sorry. We're trying to find the value here. So here y is 0, the point, this point y is 0, and our x is c. Y is 0 and x is c. So this y here is going to become 0, and this x here is going to become c, is the point we are looking for. So this is going to be 0 is the same as f of a plus f of b minus f of a divided by b minus a multiplied by c minus a. Further, to find the value of c, the subject of the formula. So I'm just going to copy this and go to the next page and show you how can we make c as the subject of formula. Copy it, and we come here. Okay, so let's make c the subject of the formula. So we're going to take this to the other side, which is going to be minus f of a. We write this the way it is. It's going to be this divided by b minus a multiplied by c minus a. So you take this, you multiply by that. This can be multiplied, and you're going to get b minus a is equal to f of b minus f of a and c minus a. So here again you can multiply this out here. So when you multiply this thing out, you are going to have, this is going to be minus b f of a and plus f of a plus a times f of a, which is equal to it's going to be the same as this one here. You multiply this out, so you don't want to get this rid of c, so therefore you're going to take this, you're going to say this is the same as c, f of b minus f of a, and this is the same as minus a times this, which is going to be minus a f of b, and one more thing is this one, it's this and that, which is going to be plus f of a plus f of a. So this and that are the same, this one and this one are the same, so we can just cancel this out. So you are going to and take this to the other side, so you are going to left with this minus b f of a plus a f of b is equal to c f of b minus f of a. So you make c the subject, so that means you divide both sides by c, you get c is the same as a f of b minus b f of a divided by f of b minus f of a. So this is the formula that we are going to use to find our c now. So after finding c, we are proceeding with the same procedure for bisection. You find c using this one, and then after getting c, since now you had initial interval which was a and b, and now you have c, which is the element of a and b, you check whether f of the root lies between f of a and f of c. That means if you multiply it out, b times f of c, you do the same thing. If this gives you 0, therefore the new interval is going to be a, and that's c. Again, to find the new c here, so after finding the new c, you do the same thing. You are going to see the procedure. We're not doing the actual example, but you can see that as you continue reducing the interval, at some point your interval is going to be between here and there, and at some point your interval is going to be between here and here at some point. So this is going to be your interval. At some point you see that you're getting close, this point here is getting close to this point here. At some point your interval is going to be extremely slow in such a way that's on that your C is on that position you are looking for. All right, so keep on watching. In the next video, we're going to do the actual example.